Okay, so as I was saying, here, we will shift this to the first significant figure, which is 3. So we shift it to 3. We count the number of decimal places which we shifted. We have 1, 2, 3. Keep the 3 known there. If it is 3.04, you're going to have 3.04 times 10 to the power 1, 2, 3. This 3 is a 10 to the power 3. Same 3. Okay, so that is all for the conversion of numbers to standard form. Let's go to the next, which is operations in standard form. So we are going to do operations like multiplication and division of numbers in standard form. So you like the board. Then I can write this. Okay. So let's multiply 2 times 10 to the 3 times 3 times 10 to the 4. 2 times 10 to the power 3. All of this times 3 times 10 to the power 4. So how do we do this? Do this, we just multiply the numbers that we have. We multiply the numbers that we have without these tens first. So we will have 2 times 3. We put our bracket. Do 2 times 3. Put our bracket into bracket. Now we open another bracket. And then we put. Okay, we can put the times in the middle. Or if you want, you don't put it. Okay. This is how we're going to do it there. Today. Then you put your times 10 to the power what? How do I know the power? This will be 3 plus 4. 3 plus 4. Why 3 plus 4? Because when I multiply 10 to the power something and 10 to the power something again, I add the powers. So during multiplication, I add the powers. From the laws of indices, we do that a to the power n times a to the power n is equal to a to the power n times a to the power m is equal to a to the power n plus m. So this is the same like 10 to the power 3 times 10 to the power 4. 10 to the power 3 times 10 to the power 4 is same like 10 to the power 3 times 3 plus 4. 90. 2 times 3 is 6 times 10 to the power. What is 3 plus 4? 7. And this will be the final answer. So let's take another example. Two 0.5 times 10 to the power minus 3 times 4 times 10 to the power 3. This was going to be the answer. So this is equal to, you do this times this, You first do this answer, this one here. Open your bracket. 2.5, this 2.5 times this 4. I do times 10 to the power this and this. It is 10 to the power minus 3 plus 3. Like the rule says. 10 to the power, I first write the first one, minus 3. The second one is plus 3. The second power is plus 3, so right? Plus 3. So I am going to have, what is 2.5 times 4? 10. Yeah. Times 10 to the power minus 3 plus 3. What is minus 3 plus 3? Minus 3 plus 3 is the same like 3 minus 3. So minus 3 plus 3, you consider it is 0. Because it's the same like 3 minus 3, which is equal to 0. So it is the same like 10 times 10 to the power 0. And we know that anything raised to the power 0 is 1. So 10 to the power 0 is 1. Which means this should just be equal to 10. But we know that 10 is not in standard form. Because 10 is 1 and 0. That is already 2 digits. So it is not in standard form. So how do I put 10 in standard form? 10 is going to be equal to, as we have learned, I put my dot here and I shift it until I see the first figure. The first figure here is 1. So I shift it until I see this one. How many times did I shift it? 1 time. So it is 1 times 10 to the power 1. 10 to the power 1 because I shifted it 1 time. That is the final answer of standard form. So let's do some division. We're going to have 5, 6 times 10 to the power 5. All of that divided by 2 times 10 to the power 2. How do I solve this? 6 times 10 to the power 5 divided by 2 times 10 to the power 2. So we do as well. Here we took 2 and 3 to sign. So we're going to do same here. 6 division sign. So it's going to be 6 divided by 2. You not put times 2. You see here that I'll put 2 times 3 because of the times is here. Since now division is here in the middle, I put divided by. I don't put times again. You get? So I have 6 divided by 2. Now times 10 to the power. This here, this outside here, it must be times. So you will not say that this thing will become divided by. This divided by enters the middle. That's when it makes the difference. And the divided by makes also the difference on the powers. Because this will be times 10 to the power what? So we have done 6 divided by 2 here. We have to also do 10 to the power 5 divided by 10 to the power 2. So what is 10 to the power 5 divided by 10 to the power 2? Well, let's go to our rough work. Here's our rough work here. 10 to the power 5 divided by 10 to the power 2. what is it? It's the same like 10 to the power 5 minus 2. Multiplication, it was 10 to the power 3 plus 4, which gave 7. That was because it was multiplication. 3 plus 4 is coming from here and here. You add the powers. Now, since it is division, you do times 10 to the power and you subtract the powers. You see, normally I did this 6 divided by 2. I also have to do this 10 to the power 5 divided by 10 to the power 2. Okay, let me even write it. 10 to the power 5 divided by 10 to the power 2. Or we want to keep the same division sign like I did here. Divided by 10 to the power 2. So 6 divided by 2 is going to be what? 3 times 10 to the 10 to the power 5 divided by 10 to the power 2 is the same like 10 to the power 5 minus 2, which implies the answer is 3 times 10 to the power, what is 5 minus 2? 3. So you have to know that a to the power n divided by a to the power n is equal to a to the power n minus m. When you are doing division, you subtract the powers. And when you do multiplication, you add the powers. So another way of doing that. Okay. The power 5. All over, we write this 2 times 10 to the power 2. Just like that. 2 will cancel here. 1 time. Here 3. Here, I have 10 to the power 5 divided by 10 to the power 2. How do I do the division? I do. That is going to be 10 to the power 5 minus 2. I'm going to subtract 2. You see? Because the powers, the base is the same. The base is 10, 10, 10. The powers are different, so I'll subtract the powers. I have 5 minus 2, which is going to be 3. So the answer here is going to be 3 times 10 to the power this 5 minus this 2. Because it is under, I bring it up and I put minus. So I'm going to have 3 times 10 to the power 3, just like that. You can do like this and you're still going to have the answer. So, yes, form. So let's go to the next exercise. Well, I think we did some exercises already. Yes, I think we did some exercises already. Okay, let's do some exercises again. Let's do some exercises on these two. Again, to record. So, first exercise. What's the first exercise going to be? It is write 567,000 in standard form. Standard form. SF means standard form. So in standard form. So pause the video, do it, write it in standard form. and you can play it back to see the correction. So what is 5,600? What is 567,000 in standard form? So in standard form, I'm going to put my, since there is no decimal place, it's not giving me any decimal place. I'm going to put my decimal place here and shift it until the first digit. The first non-zero digit, the first non-zero digit. So 2, 3, 4, 5 times. I stop at 5 because it is immediately to the right of the first digit. So I'll have 5 point, I'll write the 2 digit I see, 6, 7. After it, I have no other 2 digit. I have no other non-zero digit. 6, 7. Okay, I write it times 10 to the power 1, 2, 3, 4, 5. 5. I write times 10 to the power 5 because I shifted it behind. So I write times 10 to the power 5. The next exercise says write 0.000089 in standard form. Okay. Write 0.000089 in standard form. We have to write this in standard form. So how do I write it in standard form? I start from my decimal point. This is my decimal point here. I start from it. And I move to the right this time. I move to the right because the first digit is on the right. The first digit is here. Here I move to the left because the first digit was on the left. So I'll place my decimal point until I come to the right of the first digit. Until I come immediately at the right of the first digit. You see, it was immediately at the right of the first digit. Also here, I put it immediately at the right of the first digit. So I shift it until I reach here. I shift it how many times? 1, 2, 3, 4, 5. I shift it 5 times. So it is going to be 8.9. 8.9 times 10 to the power, I shifted it 5 times. So it is minus 5. Why minus 5? Because I shifted it to the right. When I shift it to the right, I put minus. When I shift it to the left, I put plus. You have to keep this in mind. If you are putting a big number in standard form, your power will always be positive. So it will always be plus. It will always be a plus number. If you put a very small number in standard form, is 0 point something, your power will always be a negative number. So next, 4 times 10 to the 6 times 2 times 10 to the 3. Four times 10 to the power 6 times 3. 2 times 10 to the power 3 times 2 times 10 to the power 3. So as we said, I will multiply first the digits. That is going to be equal to 4 times 2. 4 times 2 in the bracket. 10 to the power, since I am multiplying from this law of indices, I know that when the base is the same, I add the powers. So the powers are 6 and 3. Give it to the power 6 plus 3. We add powers. So that is going to be, what is 4 times 2? 8. 8 times 10 to the power 6 plus 3, 9. And that is it. So that's how you evaluate that. So the next example says convert 3.2 times 10 to the power 4 to ordinary form. Convert 3.2 times 10 to the power 4 to its ordinary form. So we can see that this is in its standard form. So you have to convert it to its ordinary form, like a form like this one, which is not in standard form. So how are you going to go about it? So we have been trying to convert it to standard form, but we have not tried to convert it back to its ordinary form. So from the exercise that we have been doing, we recall that 4 was the number of times which we moved the decimal place. 4 is positive. It means the decimal place was moved 4 times behind before reaching 3.2. Because it is positive. When it is positive, it means it was moved 4 times behind. 1, 2, 3, 4. Then it reached 3.2. So we can just put the zeros here to go back to the former place. So if I write back the zeros everywhere, I'll see that our 0, 0, 0. You can test it to see if it is true. Standard form. And 4-digit numbers, 4 decimal places to have this. So what I did to have it, there are actually many methods. I'll show you the method which I did. I'll show you another method which I think will be easier for you to grasp. So what I did, I just considered that it was shifted 4 times. So 1, 2, 3, 4. And when it was shifted those 4 times, normally the 3 was here. So I write my 3 there. And then since it is 0.2, I write 0.2. Because I have 3.2, so I write 3.2. And then these 4 are zeros. Because there's no other number there, so it is 0, 0, 0. So when I try to go back with the decimal place, 1, 2, 3, 4, I'll put my point here. I'm going to have 32,000. 32000. 32000. As easy as that. Or better still, you can still write just this. When they give you this, you can just do 3.2 times the actual 10 to the power 4. 10 to the power 4 means 10, 1 and 4 zeros. 10 to the power 4 is 1 with 4 zeros because the power is 4. 1, 2, 3, 4. Are you saying? This is 3.2 times 1, 2, 3, 4. 10,000. So when you to be your answer, you will just shift this decimal point 4 times. 1, 2, 3, 4 times, because there are 4 zeros. You shift it 4 times in front. That is actually the method which is used in school. I'm sure this is the method which will be used in your class, which was used or which will be used. So you have 3.2. If I shift it to 4 decimal places, because I'm multiplying by 1000, I have 1, 2, 3, 4. So I fill with the zeros. 0, 0, 0. I think my decimal point is not more here. I moved it from here to here. It means the answer is 32000, then the decimal point 32000. If you want to put this decimal point, if you want to leave it, it is still correct. You see, the two methods give the same answer. I'll advise you to use this method because that is the method which will be used in your school. That is the method which will be recognized by your teacher. If you understand the two, it's fine. So, okay, now we'll go to 1.3, which is approximation and significant figures. I've done with 1.2 standard forms and scientific notation. So I hope you have understood how to convert the number from normal form, ordinary form to standard form, and from standard form to ordinary form. And then I hope you have understood how to do multiplication and division of standard forms like this here. So now we are going to approximation and significant figures. So I'll wipe all of the board. Significant figure rules. So the first rule, on all non-zero digits are significant. So firstly, all non-zero digits are which shows this rule that all non-zero digits are significant. Zeros between non-zero digits So zeros between non-zero digits are significant. Thirdly, leading zeros are not significant. Leading zeros are not significant. Fourthly, trailing zeros after decimal points are significant. Trailing zeros after decimal points are significant. So let's look at examples concerning all of them. So for the first one, they say all non-zero digits are significant. For example, if you have a number like 4, 5, 6, 7, here, how many significant figures are there? It was said that all non-zero digits are significant. We have 1, 2, 3, 4. All of the digits are non-zero digits. So 4 significant figures. 4 significant figures. The second one says zeros between non-zero digits are significant. So, for example, if you have 4, 0, 0, 7, these are zeros between non-zero digits. So they are significant figures normally because they are between non-zero digits. 4 is not 0. Non-zero digits means digits which are not 0. 4 is not 0. 7 is also not 0. So this has 1, 2, 3, 4. Four significant figures. So the next one says leading zeros. Leading zeros are not significant. What are leading zeros? Example 0, 4, 7. Leading zeros are these 0, 0, 0. Leading zeros means the first zeros, the zeros that start. Leading zeros are not significant. So how many significant figures are there? We have 2 because there are 2 non-zero digits. We said all non-zero digits are significant. So there are 2 significant figures here. You write 2 significant figures. Then for the last one, trailing zeros after decimal points are significant. If there's a trailing zero after here, it's not significant. If you have this, you still have 4 significant figures. So trailing zeros after decimal points are significant. So if you have 4.500, this is going to have how many significant figures? This is actually going to have 1, 2, 3, 4 significant figures. Why? Because these zeros are also counted as significant figures because there are zeros after a decimal point at the end of a decimal point. Like the decimal point ends with 0, 0, so they are significant figures. So why are they significant figures? Because they show the precision. They show the precision of the number. 4 significant. It has 4 significant figures. It's like that. Okay, so all of those are the 4 rules which you have to know. I'm going to give some exercises to see if that was grasped well. So how many significant figures are in 0.04070? Very beautiful exercise. How many significant figures are here? I'll invite you to pause the video. Try to answer it by yourself, then come back and check the solution. Okay, so how many significant figures are here? So a 0 immediately after a decimal point is not a significant figure. You say leading zeros are not significant. So leading 0 means first 0. This 0 and this 0, they're not significant, so you cannot count them as significant values. So here we have a first significant figure. Remember, first rule, all non-zero digits are significant. So 4 is significant. Here 0 will also be significant. Why? Rule 2 says zeros between two non-significant digits are significant. We have a 0 in between 4 and 7. So the 0 is in between two non-zero digits. So 0 is also a significant value. 7 is a significant value because remember rule 1, all non-zero digits are significant. 0, is this 0 a significant value? Is it? Yes or no? Yes, it is. Why is this 0 a significant value? You see, trailing zeros after a decimal point are significant. So trailing zeros mean the last zeros after a decimal point. They are significant values. So here you have 4 significant values. 4 significant. Same thing. How many? Okay, 4.007024. How many significant figures are here? So let's start. Is 4 a significant figure? Yes. All non-zero digits are significant figures. So if you see a number anywhere that is not a 0, don't doubt, it is significant. So we have one significant figure. Point 0. Is this 0 a significant figure? Is it? Yes. Because, no, actually it is not. Zeros between non-zero digits are significant. This 0 is between a non-zero digit and there is not a non-zero digit after it. So it is not a significant figure. It is same for this 0 here. There is this 0 behind and this 7 in front. This 7 is a non-zero, but this 0 here makes it to be a non-significant figure. Just like here, these two zeros are not significant figures. If you check rule 2, zeros between non-zero digits are significant. Rule 3, leading zeros are not significant. Well, the first zeros are not significant. It will be the same here. These are not significant figures. So you are going to have this, 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 and this. 7 is significant. This 0 is in between two significant figures. And 4 is a significant figure because it is a non-zero digit. So you're going to have 1, 2, 3, 4, 5. 5 significant figures. So yeah, that is it. That is it. That is it for significant figures. So we are going to the last one, which is rounding to n significant figures. We are going to round numbers to n significant figures. So I'm just going to write this one. Rounding to n significant figures. Okay, so what is the rule to round to n significant figures? N plus 1 digit. N plus 1 digit just means the next digit. If it is greater than or equal to 5, you round up. So, for example, let's round 4, 5, 6, 7, 8 to 3 significant figures. How do we round 45,678 to 3 significant figures? Some people will say to 3 decimal places. It is the same thing. So how do I round this to 3 significant figures or to 3 decimal places? Actually, I put the first 3 significant figures. The first 3 significant figures are what? 4, they are 4, 5, and before putting the 6, they asked me to put it in 3 figures, 3 significant figures. No, it is not the same like 3 decimal places. It is 3 significant figures, very different from 3 decimal places. So if I want to put it to 3 significant figures, I'll write the first 3. But before writing the third one, I'll look at the n plus 1 term. So since our n here is 3, n plus 1 term means 4th term. I'll look at the number after the 6. Why after 6? Because 6 is my third. To know whether I will write 6 or I'll write 7, I will look at the next. If that number after the 6 is I will write. I check it at 6 because it said 3 decimal places, and 6 is my third. If they had said 3 significant figures, if they had said 4 significant figures, if they had asked me to change it to 4 significant figures, what would I have done? I would have written 4, 5, 6, and then doubt on 7. Look, check at the number after 7. Is the number after 7? Yes. Increase the 7 to 8. If not, if it is less than 5, I keep my 7 and I write 0. In this case, the number after 7 is what? Is 8. It's greater than 5. So I will change this 7. I will add 1 to 7. And I change this to 0. Exercise. Let's come back to the exercise. This year they said 3. 3. So to convert this to 3 significant figures, how do I do? I'll write 4, 5. On my third term, I'll look at the term after it. Is it more than 5? Yes, 7 is more than 5. So instead of writing 6 here, I'll write 7. I don't write 7 because this number is 7. Even if it was 9, I would have written 7. I just add. If here I have 6, and here the number that is here is bigger than 5 or equal to 5, I will increase 1 to this number. So this number will shift from 6 to 7. And then two other numbers. So that is how it is done. Let us take another example. 4, 6, 4, 5, 3. Significant figures. Let us write this to two significant figures. So, significant figures, which is 4. I'll write 4. And since they said 2, I check the second digit. The second digit is 6. The next digit after the 6 is less than 5. I can see that it's less than 5. So I keep my 6. And then what do I do? At the place of 4, this is my solution. I have put it in two significant 0.004835. Two significant figures. Two significant figures. So how do I put this value to two significant figures? Well, what I do is, I know that leading zeros are not significant. So this is not significant. This is not significant. This is my first significant figure. So how do I write it? That will be equal to, I don't write 4. I'll not just write 4. No. I write all of them. 0.00, then my first significant figure, 4. My second significant figure is what? 8. But before writing it, I check the next digit. Is the next digit greater than 4, greater than 5? No, it is less than 5. So I keep my 8 constant. I leave it as 8. I keep the 8 same. If this digit here was greater than 5, I would have changed this to 9. Because they said if it is greater than 5, I should round up. Round up means add 1 to the normal digit that was there. So since it was normally 8, I add 1 to it and I have 9. But since the number after 8, after the second significant digit, which is 8, since the number after it is less than 5, I keep my 8 constant and I write 0, 0. I write 0, 0 because there are two numbers left, 3 and 5, so I replace them by 0, 0, so that this will not be significant. So I don't even write it. If I write 0, 0, I'm supposed to have two significant figures. So I write 0.0048 because remember, zeros after at the end of a decimal point is trailing zeros. Trailing zeros after decimal points are significant. So if I write 0, 0 here, it will mean I have 1, 2, 3, 4 significant values. Significant values. So I leave it as 0.0048. So this is the answer in two significant values. If you check, you'll see that this number has just two significant values. So let's do another example, the last example. Let's write it here. So 123.47 number in significant figures. So you have to write this number to 4 significant, and to change this number to 4 significant figures. How are we going to do it? To change the number to 4 significant figures. So this number first has how many significant figures? It has 1, 2, 3, 4, 5, 6 significant figures. And to change it to 4. So to change it to 4 significant figures, I write the first 3 significant figures. I'm going to have 1, 2, 3 point. These are my first 3 significant figures. I look at, before writing the 4, I look at the value after it. After it, I have 7. Now, is 7 greater than or equal to 5? 5. What do? I round up. So when I round 4 up, I'm going to have 5. And this is going to be the answer. I don't actually write 0, 0 here because it is going to add the number of significant figures. If I write 0 and 0 here, I will have 6 significant figures because those zeros will be after a decimal point. And remember, trailing zeros after a decimal point are significant figures. So I leave it like this, and they are in 4 significant figures. So that was all for the first topic of number systems. Yeah, we are going to give some exercise videos where we are going to solve some exercises and give their answers. So there you can practice well again on the topic. So thanks for watching with us, EducQuiz. Keep watching with us so you can keep learning.